Okay, for our first chapter, so it's going to be on the fundamentals. As I mentioned to you before, it's something that you have seen before. It's just going to be on factoring and fractional expressions. Right, so this is going to be overview. We only have like 2 topics. So topic number 1 will be on review of factoring. So there are 5 ways of factoring. So common factor, difference of squares, trial and error, sum and difference of cubes, and also grouping. So we're going to have a look at each of them. And the second subtopic is going to be operations on fractions. So it's just going to be operations that involve multiplication and division, and also addition and subtraction. So those are going to be like very common operations that you have already performed before. Okay, before I start with the topic on factoring, so I would like you to be familiar with these 2 terms right here. So the first term is called as being reducible. So the second term is called as being irreducible. So usually we use this for factor. For example, if I have some like this, so I have x squared minus 1 or x squared plus 1. So from here, I can tell whether or not this is reducible or irreducible. So based on the definition of the term itself. Okay, so what does it mean by being reducible? So reducible means when you have a function, so the function can actually be factorized. So when the function can be factorized, it can be reduced to factor with smaller power. For example, this one, so it starts with a power of x to the power of 2 is actually reducible. I can actually reduce to a factor of x plus 1, x minus 1. Now this is power of 1, so that is called as being reducible. You change it from that function to a factor that has smaller power, so which is x to the power of 1 and x to the power of 1 for this case. And when you have x to the power of 1, so this is called as being linear factor. Okay, so that is going to be the first one. So it can actually be factorized, so it's called as being reducible function. For example, I have 2 over here. So the first one is x squared plus 3x. So this can actually be reduced to, if you have a look, both the common term is going to be x. I'm going to factor out the x, so I'm going to have x multiplied by x plus 3. So I reduce that to 2 linear factors of x to the power of 1 and also x to the power of 1. And the same goes for number 2 right here. So what I can do is I can actually factorize this to linear factor. So I'm going to have 3 and 1 and plus and also minus. So again, so when we can factorize, make it into a smaller factor with a smaller power than we previously had. So that is called as being reducible function. Right, so how do you know it's reducible? So what's the rule of thumb that when we have a look at that function, we can tell it's reducible first? By just eyeballing it. When you have a look at this, like for this one, you know that they have a common factor of x. So you could know that it can actually be factorized. So that is going to be one way. Second way is by using the calculator. So what you can do is, remember how we can actually find roots by using our calculator? So you find the value of a, b, and c. For example, what is a, b, and c? So your equation is going to be in terms of ax squared plus bx plus c. And in your calculator, you have to plug in the value of a, b, and c. And they will give you the roots. Okay, there will be 2 roots because this is x to the power of 2. So there will be 2 roots. For example, so it's going to be a value of y and z. Okay, if you have x to the power of 3, then it will be 3 roots and so on. What happens is that if you plug in the value of a, b, and c in your calculator and you find the roots, if the calculator gives you real numbers, then that means that the function is reducible. For example, if I were to referring to this previous example right here, so I will get a roots of x equal 1 and also x equal negative 3. Because in your calculator, how do you count that? This is actually going to equal 0. So x minus 1 equals 0. So x is going to equal 1. So that's why when you write it, it's going to be x minus 1. Okay, so I'll tidy that later so that you don't have all these things. Okay, so that is going to be the case when you use your calculator and you get real numbers. So that is going to be an example of a reducible function, meaning that you can reduce that. Your calculation is going to give you real numbers. So basically, what are real numbers? Real numbers are numbers that are real. Okay, for example, there could be numbers what you have seen before, 100, 50, those are real numbers. It could be in terms of fractions, 1 over 2, 3 over 5, so that's still real numbers. Or it could be in terms of decimal places, 1.25, 1.3, so those are called as being real numbers. Right? And the second term I would like you to get familiar with is going to be irreducible. So what happens is that when you come across irreducible function, so the features is that it cannot be factorized. So what happened is that you're going to come across something when you plug in into the calculator. So they are going to give you complex number. Okay, instead of real numbers like 150, 1 over 2 that we have seen before, what happens is that when you find the roots in the calculator, you give the calculator value of A, B, and C. So the calculator is going to give you complex number. So what is a complex number? Complex number, the features is that you can have I in there. For example, so if your calculator give you x1 is equal to plus I, and x2 give you a value of 2 minus I. So this is an example of a complex number. The special features about complex number is that it's going to have imaginary part. So this part over here with I, it is called as being the imaginary part. So this 2 is a real number. It's called as being a real part. And this is actually 1I. So this is being the imaginary part. So when you have I in your number, it is called as being complex number. And if I were to refer this to these two examples, so how are this being, being irreducible? Because when I have x squared plus 1, so I plug in into my calculator. So in my calculator, I write that A is going to equal 1 because this is 1x squared. So B is going to equal 0 because here for x, I don't have x to the power of 1. My C value is going to equal 1. When I put it into the calculator, it will give me a roots of x1. The first root is going to equal I, and the second root is going to equal negative of I. Remember, when you have I, automatically that is going to be a complex number. So when you have complex number, you cannot factorize it. You cannot write it in this form. That is not possible. Okay, and for the second example, so I have another one, which is x squared plus 2x plus 5. So it's going to be the same idea. So what happens is that when you find the roots of this, so you will get that the first root is going to be negative 1 plus 2i. You can try this for yourself with your calculator. And you will get that the second root is going to be negative 1 minus 2i. And because of the I that we have over here, automatically this is going to be a complex number. So meaning that these two functions over here, they are irreducible. Can you factor them? No. So the only way you can do is you have to leave it as it is. Don't factorize them. There's no way it can be factorized. Okay, so that is going to be the two terms that I'm going to be introducing to you. You're going to hear this in the lecture, reducible and irreducible. Now you get the idea. You can factorize it, reducible, cannot factorize, irreducible. Okay, now let's have a look at the review of factoring. So factoring is an act of expressing polynomial as a product. So we have a polynomial that looks like this. We're going to make it into a product of a simpler function. So here I started with x to the power of 2. I'll make it into linear factors, x to the power of 1 and also x to the power of 1. And same goes for what I have over here. So y to the power of 3, I noticed the common features between them, which is going to be y. So I factor y out. And I have another two factors for which this is going to be, when you use your calculator, this is going to give you real roots. For this case, you will get x equal 4 and also x equal negative 4. And for this one, you will get y equal 0, y equal 1/3, and y equal negative 1 over 3. Remember, when you have y by itself, so this is actually y plus 0. Okay, it's going to be referring to this one, y plus 0, y equals 0. Okay, so there are 5 factoring techniques that we're going to have a look at, as I mentioned to you before. So how are you going to do it? You're going to factorize your function over and over again until they are no longer reducible. Okay, until you cannot do anything about it anymore. Okay, so this is what I've introduced to you before, which is irreducible function. Okay, how do we know when to stop when we do factorization? So it's going to be something like this. For example, here I have x cubed plus 2x squared plus 5x. When I start factorizing, I notice a common feature between them, like all of them consist of x. So I'm going to do first is, I'm going to factorize the x. I'll end up with x squared plus 2x plus 5. So this is a linear factor, it's x to the power of 1. So that is the smallest it can be for polynomial. The smallest is when you have your variable raised to the power of 1. Because raised to the power of 0, it will be constant. Okay, it's not polynomial. Okay, here I have x to the power of 2. Now I have to think about, should I stop here or should I proceed? Okay, so stop or proceed. So how do you know which one that you have to do, whether you're going to stop or proceed? So depending on the nature of this function right here. So what you have to do is you have to put this function into your calculator and find the roots. If it's going to give you a real number, factorize it further. If it's going to give you complex number, it is irreducible, then stop there. And for this case, we have seen this before. This is one example that I gave you before. So this is an example of irreducible function. So therefore, there's nothing you can do about it anymore. So what you have to do is stop. Okay, so basically if you have x cubed plus 2x squared plus 5x, so this is going to be the factorization that you're going to do. But if it is reducible, so do it further, make it into smaller linear factors. Okay, so the first technique that we're going to have a look at is going to be the common factor. So this is going to be the easiest one. So how do we do common factor? So let me add a page right here. Is you have a look at what is common between the functions. Okay, so the first one, it's a very simple example of 2x squared plus 4. So what is common between these two? The variable, only the first term has x squared, the other term doesn't have x or anything. But what I notice, what common between them is going to be the constant 2 and 4. So what happens is that both of them are multiple of 2's. So what I'm going to do is I'm going to factor out the 2. So when I factor out the 2, the first term is going to end up as x squared and the second term is going to be 2. So can I reduce this further? So what happens is that I'm going to check this. So put this into the calculator. So when you put it into your calculator, you will get complex root. If I'm not mistaken, you're going to get like plus minus square root 2 of I. So you will get complex roots. So what does it mean by that? So it means that this function is actually irreducible. You cannot factor anymore. So just leave it like this. So this is going to be the factorization. Stop at that. Okay, so that is going to be the first example. Okay, second example. So I have 2x to the power of 4 plus 8x cubed plus 10x squared again. So I have to look what is the common term between all the term. So I noticed that so each of them is a multiple of 2. So I have 2, 8 and 10. So that is the first feature. And the second feature is that all of them is actually consists of x variable, so raised to the different power. But what is the smallest power? The smallest power is going to be x to the power of 2. So that's why when I choose to factorize, I will factor out the smallest constant and the smallest variable. So it's got to be 2 and also x to the power of 2 for this case. And for the first term, I'll end up with x to the 2 plus this is going to be 4x and the last term is going to be 5. Okay, so that is how it goes. And I'll end up with 2x squared multiplied by x squared plus 4x plus 5 again. So it's going to be the same deal. So this one I have to check whether it's going to be reducible or irreducible. I think this one is irreducible. So let me check that first. So use your calculator to check that. So here my value of A is going to equal 1, value of B is going to equal 4, and my value of C is going to equal 5. Yeah, I got, so the roots is going to be negative 2 plus minus I. So the first one is going to be negative 2 plus I, the other one is negative 2 minus I. Okay, so therefore it is the second case, which is irreducible. So we just leave it like this because we know that we cannot factor x squared plus 4x plus 5. Right, so I'm going to do the same to the third one. So the third one, I have 3 multiplied by, so let me see it from my computer instead, so that you wouldn't get confused with all that going up and down. So 3 multiplied by x squared plus 2. So minus x multiplied by x squared plus 2. So it's going to be the same idea for this one as well. So what we have to do is we have to look at what's common between these two. And I noticed that both of the term consist of x squared plus 2, meaning by. So that is going to be my factorization. So I'm going to factor out x squared plus 2, for which in here, the first term I'll end up with a 3, and the second term I'm going to end up with an x. And I'm going to leave it like this. So this is how it should be, because why? Because this one, it is going to be irreducible, right? X squared plus 2 will give you plus minus square root 2 of I. It's irreducible. And this is already linear, x to the power of 1, the smallest it could be. So therefore, this is going to be our factorization. So if you can factor it further until it is no longer reducible.